Hello everyone. In this video lecture, we'll discuss about pure virtual functions and abstract class. So last time we have already discussed about runtime polymorphism or dynamic polymorphism, wherein we have used virtual keyword. Okay, so virtual keyword is used to request a compiler to go for late binding. Okay, so today we are going to discuss about pure virtual functions. Okay, so let us discuss the syntax of it first, how to use pure for virtual function or how to make any function as pure virtual, and then we'll discuss the relevant application of it. Okay, so first let us discuss about how to make a function as pure virtual function. So in this case, what I have done, I've declared one class A. In class A, some variable X is declared, okay, and there is a constructor, okay, constructor to assign value to this X, to initialize the value of X. Then I'm having one for function, calculate function here, void calculate, okay, and I've made this function as virtual function. That means what? I'm going to virtual function. When do we use? When I'm overriding this function in the derived class. So this class B is what? It is derived class. Okay, I'm inheriting this class A here. So B is a derived class. In derived class, if I'm using the function with the same signature, okay, void calculate. So this is the case of function overriding. So whenever I'm using function overriding, and if I want a runtime polymorphism, I'm using this virtual keyword. Okay, so that's the reason this virtual keyword is there. Okay, but last time what we have seen, this virtual function, this function we have defined there itself. Okay, here itself we are adding the definition of this particular function, and we are having some code related to X variable. Okay, now let us assume that as per the requirement of my application, I don't want to define this function here. I just want this function to be there, but I don't want to define it. Okay, so in that case, if I don't want to define this function in this class, in that case I have to assign zero value to it. Simply declaring it and not defining it anywhere will give me error. Okay, so instead of that, what I'll do, I'll make this or I'll just assign zero value to this functions. That means compiler will understand that there is no definition for this calculate function in this class. Okay, so if I don't want to define it, I'll just assign zero value to that function. Okay, now this type of declaration of function is called as pure virtual function. Okay, this is called as pure virtual function. Okay, so this definition, that is making, first thing is that we are making that function as virtual. Okay, to request a compiler for late binding. So that's the reason this virtual keyword is there, and that means it is virtual function. But why we are calling it as pure virtual function? So the reason is that I'm not defining its body anywhere. Okay, in this class I'm just assigning zero value to it, so it does not have any body here. Just this declaration, pure virtual function declaration is there. That's the reason I'm assigning this equal to zero. That's the reason it is called as pure virtual function. So just by adding this equal to zero, I can make that function as pure virtual function. So this is pure virtual function. Now rest of the thing, like previously also we have discussed, same thing I'm doing here. Class B, I'm inheriting class A. Here one variable y is declared. This is the constructor to assign initial value to y. Okay, and again now here I'm overriding this calculate method. Okay, overriding. So exactly same signature I'm using, void cal and without any parameter. And here in this calculate function, I'm calculating the addition of x and y. Now this x and y, x is available through inheritance to this function, to this class. So x and y value is available here. Already x we have initialized in the constructor. Similarly, y we have initialized in the constructor. So already x is holding 10, y is holding 20, and that addition we are displaying in the calculate. So calculate function is to add these two value as well as to display the result on the screen. So we are defining this calculate function in the derived class, but not in the base class. Okay, so if the situation arises in your application wherein in base class you do not want to define that particular function, okay, but in the derived class we want to force that it should have that function, we want to make it compulsory to the derived class to hold that function or to define that function. In that case we can have a pure virtual function. So pure virtual function makes it compulsory for the derived class to define this particular function. Okay, so this class B should have this void calculate function, okay, which is it is already having. Okay, so compiler, if we want to make it binding to the programmer that all derived classes should have this calculate function, okay, so in that case we can make it as a pure virtual function. So whenever this type of pure virtual functions are there, and when you are inheriting those classes, here I'm inheriting that class, so it it makes it compulsory to class B to define this function. Okay, so this it should have the definition of this function. Okay, now coming to the next part, that is how to declare the object for these classes. Okay, so let us discuss declare the object here for A class. Okay, and then we can declare the object for the B class. Sorry, B class object I have declared. Now let us see whether it is accepting this type of declaration. Yes or no? No, it is giving me error. What is the error? See here, abstract class. A is a abstract class. Now why it is calling A as abstract class? Because this pure virtual function or method calculate is available in that class. So whenever pure virtual function is available in any class, it is called as abstract class. This class automatically, there is no keyword as such abstract. In Java language that keyword is there, abstract keyword is there, but in C++ abstract keyword is not available. Automatically whenever pure virtual function is there in that class, it will be treated as a abstract class. Okay, so automatically it will be treated as a abstract class. So and the rule with abstract class is you cannot instantiate it or you cannot create the object of abstract class. So whenever pure virtual function is there, now in this case A will be treated as abstract class, meaning is that we cannot create the object of abstract class of class A. So that's the reason I'm getting this error. Okay, so this is not allowed. You cannot create the object of the abstract class. Now whether, let us see whether it is allowing me to create the object of B. Yes, it is allowing. It is not giving me any error as such. It has created. Okay, so what we have learned from this, that whenever pure virtual function is there in any class, automatically that class will be treated as abstract class. Okay, and that means you cannot instantiate or you cannot create the object of that class. But whereas if you are inheriting that class somewhere in other class, you can create the object of that derived class. That is allowed. Okay, because it is having its own definition here, and here we are having definition for calculate. So now we can instantiate this class B. Okay, but this we cannot instantiate because here if I instantiate this class with object, and on that object if I call this function calculate, does it have any definition for this calculate? No, it does not have any definition for this, and that's the reason actually it doesn't allow you to create the object of class. Okay, so abstract class cannot be instantiated. Now we have seen that we can create the object of B class. Now how to call this cal function? Now the same in the similar manner, the way we call it for object, B object dot cal. Now let us see whether it is calling it properly and we are getting the correct answer. Yes, we are getting the correct answer. Answer is 30. Okay, so this is about this is about the introduction to, excuse me, this is about the abstract class and pure virtual function. So what we have seen, pure virtual functions can be defined in this manner just by adding virtual keyword and assigning this zero value will make it pure. Adding this virtual keyword will make this function as virtual, and adding this equal to zero will make it as pure. So this is pure virtual function. Okay, that means we are not having any body of this calculate function inside this class A. And whenever this pure virtual function is there, the rule is that automatically compiler will make this class as abstract and you cannot instantiate it. Okay, so if I try to instantiate, I got the error. Okay, whereas you can instantiate the derived class and you can use that calculate method. Now, if I cannot instantiate this class A, why I need this at all here? And you might be wondering why this, if I can't instantiate and if I'm not having this body, then why we are having it here? You must be wondering. The reason is that whenever this pure virtual function we are adding, we are making it compulsory for class B. Now let us remove this part. I'm inheriting this class A, but I removed this part from here. Say I'm not having the definition of calculate function here in this. Okay, so if I'm not having that calculate method, let us not call that. Okay, and let us execute it. Now again I'm getting error. So what it is saying, now B class also is treated as abstract class. Okay, and it is saying that it is having this pure virtual function. So what has happened, through inheritance this pure virtual function is available to class B. So inheritance means what, this will become part of now member of this class B. So this is available here in class B. That means this class B is also having this pure virtual function through inheritance. So if it is having pure virtual function, the rule says that if pure virtual function is there, this class to be treated as abstract class, and if it is abstract class, you cannot create its object. So that's the reason I'm getting this error. So compiler makes it compulsory for the derived class to define this particular function. If it does not define it, then automatically this class will also be treated as abstract class. Okay, if you don't define this function in the derived class, automatically this class is also treated as abstract class. Okay, so that means what, with pure virtual function we are putting a compulsion on the derived class to define the function, and if it does not define it, then this class is also treated as abstract class. So in your application, if the situation arises wherein you want to make it compulsory to all the derived classes to compulsorily define these function. Okay, so whenever this we are inheriting class A, it should compulsorily define this particular function. If we want to make it compulsory to all the derived classes, then in that case we should have a pure virtual function in the base class. So यहाँ पे हमने क्या किया, इसे प्योर वर्चुअल बना दिया. तो प्योर वर्चुअल के साथ what will happen, that it will make it compulsory to the derived class to define it. Otherwise you will get this kind of error. Otherwise this class is also treated as abstract class and you cannot instantiate it. Okay, so in your application, if you want to make it compulsory to the derived classes to define this function, okay, so in that case you have to use pure virtual function. So now let us see, I'm defining this calculate function here and now I'm trying to instantiate it. So is it allowing it now? Yes, it is allowing, it is getting executed. So what we have learned in this example, that whenever pure virtual function is there in any class and we try to derive that derived class should have the definition of that pure virtual function. If it does not have, then in that case this is treated as a abstract class and then you cannot instantiate it. Okay, so this is as far as syntax is concerned. Okay, syntax related rules we have seen, what is pure virtual function and what is abstract class. Now let us discuss the real time application or real world application in order to understand what is actual application of this pure virtual function. So now discuss this. Let us discuss this example, wherein base class is shape. Okay, base class is shape, and I am having two derived classes, rectangle and triangle. Okay, so rectangle and triangle, these two are types of shape. Rectangle and triangle, these two are types of shape. So I will have one base class called as shape. Okay, and I will derive this shape class in this rectangle and triangle class. Okay, so shape will become the parent class, and these two will be the derived classes, rectangle and triangle. Okay, now both rectangle and triangle will be having common parameters as width and height. These are the common parameters. So let us discuss width and height in the base class, because it is common to both the derived classes. So common things we put it in the base class. So width and height we are having for both the types of shape. And now this is the constructor for the shape, wherein some input value I am passing a and b, and this a will be assigned to width and b to height. So just to initialize height and width, I am having this constructor shape. Okay, parameterized constructor. Now next point. Now can I define the area function here? Can I define the area function here? Can I have that body of this area function here? And what should be the calculation part here? How to calculate the area for a rectangle? Width and height. And how do we calculate it for triangle? Width and height by 2. Okay, so calculation, my question is here, can I have a common formula for both of these derived classes, rectangle and triangle? Can I have a common formula here? No, because the area calculation for rectangle we should use different formula, and for triangle also different formula is there. So if different formula is there, I cannot define this function here. I cannot have this common area function here. Okay, so I cannot define it. First thing is that I cannot define. If I cannot define, that means I should make it equal to 0. I cannot define it, this area function here. So I'll make it equal to 0. Okay, because there is no common formula. So I'll just simply make it equal to 0. So I'm not going to define it. Okay. Now, but in this application, what I want, whenever I'm inheriting shape class, I should have a area calculation function. In my application, I want to make it compulsory. Whenever I'm inheriting this shape class, okay, so I want all these derived classes to implement area calculation function. So if I want to make it compulsory, okay, so in that case, what I'll do, I'll make it pure virtual function. Okay, I'll make this function as pure virtual function. So with this, what will happen if it is pure virtual function? Pure matlab no body, and virtual function is what? When I'm adding this keyword here, virtual keyword. So now this is what? Pure virtual function. Okay, so whenever this pure virtual function is there, what it says that this shape will be treated as an abstract class now. This will be treated as an abstract class, and whenever you try to inherit this abstract class, all these things will be inherited. Okay, so it all these things, so it will have width and height, it will have the code to initialize width and height, and along with that it will also have a pure virtual function. So pure virtual function is also inherited here. So that means if I inherit pure virtual function here, that means what? This rectangle class will also become my abstract class. So I cannot instantiate it, but I want to instantiate it in my main function. So if I want to instantiate it, what is the solution for that? I need to define that function here. Okay, I need to define that function over here. So excuse me for this. So if I define this function over here, that means what? I'm not making this area function as virtual now. I'm actually defining. Okay, so whenever there is a definition of this function, in that case this will be treated as a normal class. It is no more a abstract class now. Okay, because this function definition will override this. Okay, so this will not remain as a pure virtual function in this through inheritance, because I have defined this particular function. Okay, so if I define it, that means what? This will be treated as a normal class and you can instantiate or you can create the object of this. Okay, similarly here also in triangle, I'm inheriting it as well as I'm defining that area calculation function, okay, which was a pure virtual function, because I don't want this triangle to become the abstract class. So I'm defining this function over here, okay, with the required formula for triangle calculation, area of triangle, and this is area of rectangle. Okay, so these two are having two different calculation method, so we cannot have a common area calculation here. That's the reason I made it pure virtual function. Okay, and through pure virtual function, what I've done, I've made it compulsory for the derived classes to define this area calculation. Okay, if this area calculation is not there, then again these derived classes will also become abstract. Okay, now as these are normal classes, I can instantiate this. So here I've instantiated rectangle class. I'm calling its uh, mm, what you say, constructor. In this also I'm calling the constructor. Which constructor will get called now? This constructor, rectangle constructor. So in this function, this constructor will get called, and in turn we are calling what? The base constructor. Similarly for triangle also we are calling the constructor, and in turn we are calling the constructor for the base class. So this initialization will take place, width and height. Okay, so first initialization will be done for rectangle, next initialization will be done for triangle. Now what we are doing, we have created the pointer for the base class, and through base pointer we are calling the function. So now last time only we have seen that base class pointer can hold the derived classes, object of the derived class. So this is the base class, I'm holding the address of the derived class. Okay, now as we have made it virtual, with virtual what we have seen last time, it will be treated as a late binding case. Okay, so on this shape pointer I'm calling area function. So which area function will get called? The one which belongs to rectangle, because at this moment in time shape pointer is pointing to rectangle, so it will call the area function from rectangle. Okay, so it will call this particular function from rectangle, and this will be displayed on the screen. Okay, so first we'll get the method calculation for rectangle. Now next is what? The same base pointer shape, same base pointer only, we are making it point to the triangle class. Okay, triangle object. In this case it is pointing to triangle. So now on shape pointer, if I'm calling this area function, which area function will get called? The one which belongs to triangle. So it will call the function from triangle, and according to this formula it will calculate the area for the triangle, and it will be displayed on the screen. It will get returned actually here, and this return value will be displayed on the screen. So now we will get the area for the triangle. So here what we are doing late binding. Okay, because through base pointer we are calling the area function. Okay, through base pointer only. So if this base pointer is pointing to rectangle, it will call area from rectangle, and same base pointer if it is pointing to triangle, it will call the area function from triangle. So this is the case of late binding, and in addition to that we are also having a pure virtual function. With pure virtual function what we are achieving, we are making it as a abstract class. Abstract class matlab, we are not letting the programmer to create the object of the shape, because in real world also we do not have any object of shape. Any shape should at least be a triangle, rectangle, circle. It should have something, actually some concrete property. As such there is no shape object in the real world also. Okay, so in real world also we do not have any shape as such. It should be either, shape should be either rectangle, circle, triangle, something. Okay, and it should have its own functions and property. Common things we can put in the base class, and the specific things we can put in the derived class. Okay, and through this pure virtual function we are making it compulsory for the derived classes to define this area calculation function. Okay, so to put, if we want to put that compulsion, if we want to make it compulsory to the derived classes to define some function, we can make those function as pure virtual function. So that is the very purpose of making any function as pure virtual function, that we are making it compulsory for the derived classes to define those function. So whenever I'm inheriting shape class, I should define that function. Okay, otherwise this class will also be treated as abstract class. Okay, so in case if you are having this kind of situation in your program, you should have pure virtual function. So let us try to execute this function, this code. So let us execute this code. See, first it is displaying the rectangles area and then area of a triangle. Okay, so it is perfectly resolving this runtime polymorphism. Like on shape, I'm calling area. Here also on shape only, shape pointer only, I'm calling area. But at this moment in time, it was pointing to rectangle. So calling the area from rectangle. And then next time it is pointing to triangle. So now it is calling the area calculation from triangle. So runtime polymorphism concept is there, and along with that, that pure virtual function is there. Pure virtual function means this is now abstract class. So whenever I'm inheriting it, I should define these function. Okay, अगर यहाँ पे ये function definition नहीं होता, in case this is not there, so what will happen? You will get the error. When you'll get the error if you try to instantiate this particular class, because now rectangle is also treated as abstract class. So this compulsion it puts, you should have this definition here, otherwise again rectangle will also become the abstract class. Okay, so in order to put this type of compulsion, we should have a pure virtual function. Yes, I hope it is clear. So maybe few more example we can discuss in the lab. So thank you everyone for attending this